Every time you caught a Pokémon in a real location, you were feeding data into a system that's now guiding military drones. Pokémon Go players have no idea they've been crowdsourcing the most detailed street-level 3D maps on the planet. And now, those maps power autonomous weapon systems. This isn't science fiction, it's happening right now, and the tech companies involved have been incredibly quiet about it. The story starts with Niantic, the company behind Pokémon Go. For over a decade, they've been collecting data from millions of players worldwide. Every scan, every location marker, every movement across a virtual map, it all fed into something called the Lightship system. Lightship creates hyper-detailed 3D models of real-world streets and buildings. What started as a way to make Pokémon Go more immersive became something far more powerful. Then something extraordinary happened. The United States military realized what Niantic had built. A company called Vantor, which develops navigation systems for autonomous weapons, partnered with Niantic to adapt this crowdsourced mapping data for military drones. Suddenly, autonomous weapons don't need GPS. They don't need satellites. They can navigate using the same street-level imagery that gamers had been generating for years. This is the moment everything changes, and almost nobody noticed. Let's rewind. Pokémon Go launched in July 2016 and became a cultural phenomenon overnight. People were walking around neighborhoods with their phones out, catching digital creatures in real locations. What made the game work wasn't just the fun, it was the augmented reality layer. The app needed to know what the real world looked like so it could overlay Pokémon on your camera view. That required detailed maps of every street. Niantic solved this problem brilliantly. They created the Lightship platform, a system that lets players contribute visual data as they play. When you scanned a location with your phone, you weren't just playing a game. You were capturing 3D visual information about that place, what the buildings looked like, how the streets were laid out, where trees and power lines were positioned. Millions of players did this thousands of times per day across the entire planet. By 2024 and 2025, Niantic had assembled something unprecedented, a global, crowdsourced, street-level 3D database covering millions of locations. It's more detailed than satellite imagery because it's taken from ground level. It shows the actual texture of the world, not just the shapes from above. Google has Street View, but this is different. It's real-time, distributed, and constantly being updated. And it was all built without most players understanding what they were contributing to. Here's where it gets interesting. Vantor, a company specializing in navigation systems for autonomous systems, realized what Niantic had created could solve a critical military problem. Drone navigation traditionally relied on GPS, but GPS has a massive vulnerability. It can be jammed, spoofed, or denied. An adversary can broadcast false GPS signals and send a drone completely off course. Modern militaries needed an alternative. Vantor figured out how to use Lightship's 3D mapping data as a backup navigation system. Instead of relying on satellite signals, a drone could navigate using visual reference to the ground, basically comparing what its cameras saw to the detailed 3D maps Niantic had built. It's like a pilot recognizing landmarks instead of following a compass. And because Niantic's data covers most populated areas globally, suddenly military drones could operate anywhere humans have played Pokémon Go. The system works through something called visual odometry and SLAM technology that stands for simultaneous localization and mapping. Basically, the drone looks at the ground, compares the visual patterns to the reference map, and figures out where it is and where it's going. This method is incredibly resilient. You can't jam it like GPS because there's no signal to jam. There's no satellite dependency. It's autonomous, precise, and nearly impossible to defeat. And it's all powered by data that came from people playing a mobile game. As of June 2026, Vantor is actively deploying this technology in military systems. The U.S. Department of Defense has been testing and integrating visual navigation into various drone platforms. Some reports suggest this technology is already in field use in conflict zones. The exact details are classified, but the partnership between Niantic and Vantor is public record, and the implications are clear. Military applications would include autonomous missions in contested areas, operations where GPS is unreliable or denied, and long-range precision strikes where accuracy is critical. A drone guided by Niantic's maps could navigate to a target location with meter-level accuracy without ever needing a GPS signal. This is a game-changer for military strategy, but it's not just the United States. Other nations are paying attention. China, Russia, and European powers all have their own drone programs. Once one military realizes they can build GPS-denied navigation from publicly available mapping data, others will follow. We could be witnessing the beginning of a change in how autonomous weapons operate globally. And the infrastructure for all of it was built by people who thought they were just playing a mobile game. How does this compare to other drone navigation systems? Traditional methods rely on GPS, inertial measurement units, and terrain mapping. These systems work well under normal conditions, but they all have vulnerabilities. GPS can be jammed or spoofed. Inertial systems drift over time. Terrain databases are coarse and outdated. Visual odometry using crowdsourced 3D maps like light chips has several advantages. It's more accurate because it uses real-world imagery that's constantly being updated by millions of users. It's more resilient because it doesn't depend on external signals. It's cheaper to deploy because the data already exists. And here's the critical part: it's global. Most other visual navigation systems work regionally or require expensive custom mapping flights. Compare this to satellite-based systems or traditional SLAM algorithms used in robotics. Those either require constant updates from space-based infrastructure or they require onboard processing that's computationally expensive. Niantic's system is different. It's lightweight, pre-generated, and geographically comprehensive. From a military perspective, it's nearly ideal. And the scariest part, most of the hard work, collecting the data, building the 3D models, updating them, was already done by civilians playing a game. This situation raises fundamental questions about data, consent, and corporate responsibility. Pokémon Go players weren't told their data would be used for military applications. Niantic's terms of service don't explicitly mention defense contracting. The partnership with Vantor wasn't announced with fanfare. It happened quietly, and most people have no idea. There's also the geopolitical angle. Whoever controls the best visual mapping data controls an advantage in autonomous warfare. Niantic's maps now represent a form of soft power. The United States has detailed street-level 3D data for most of the world, courtesy of Pokémon Go players everywhere. That's an enormous military advantage that nobody voted for and most citizens don't even know exists. Then there's the acceleration question. We're moving toward a future where armed drones can operate autonomously without human control, without GPS, and guided by training data that came from civilian sources. The ethical and strategic implications are staggering. If a military drone can navigate using visual data from a mobile game, what does that mean for sovereignty, for civilian safety, for the future of conflict? And how do we even regulate this when the technology is so deeply embedded in civilian infrastructure? Let's break down the actual mechanics. When Niantic's users played Pokémon Go and scanned locations, they captured stereo images, photos from slightly different angles. The light chip system processed these into 3D point clouds, basically millions of 3D coordinates representing the shapes of buildings, streets, and objects. Over years, this created a dense, detailed 3D model of real-world locations. For military applications, a drone would carry cameras and a processing unit loaded with these reference maps. As the drone flies, its cameras capture video. The onboard computer compares that video to the reference maps using SLAM algorithms. It figures out the drone's position, orientation, and direction by matching visual features, corners, edges, textures, between the live video and the reference map. This process happens in real time, usually multiple times per second. The beauty of this approach is robustness. If the drone's camera gets partially obscured or lighting changes, the algorithm can usually still work because it's comparing multiple frames over time. It's tolerant of weather, shadows, and seasonal changes in ways that pure GPS is not. Military systems likely layer this with inertial sensors and other inputs for redundancy. But the core navigation, knowing where you are and where you're going, comes from Niantic's crowdsourced 3D maps. We are at an inflection point. The line between civilian technology and military applications has blurred so completely that it may not exist anymore. A mobile game created infrastructure that now powers autonomous weapons. Players thought they were just having fun, but they were actually crowdsourcing the technology that nations will use in future conflicts. The questions we need to ask now are urgent. Should companies be allowed to license civilian data to military contractors without explicit consent? Should players know that their location data is being used this way? Should there be international agreements about using crowdsourced mapping for weapon systems? And how do we even begin to regulate technology that's already deployed and operational? One thing's certain, autonomous navigation using visual mapping from civilian sources isn't going away. It's too useful, too cost-effective, and too strategically valuable. Other companies will build similar systems. Other militaries will adopt them. And players of mobile games around the world will continue feeding data into systems they don't understand and never authorized. The future of warfare is being built in plain sight, and most people have no idea it's happening. Stay watching this space, because the implications are only going to get bigger.